Good afternoon, everyone. It is my pleasure to introduce this paper to you. The name is Ethical Challenges in Blockchain Network Measurement Research. I'm Jiaqi Chen from Syracuse University, and this is a joint work with my advisor, Dr. Tang, Dr. Kylie, and Yibo Wang. And here is the outline of this talk. First, I will give an introduction about how we address the how we address the research questions here, and then I'll give two cases that shows how researchers solve the ethical problems in their paper, and then I will identify some open challenges in ethical concerns, and at last, I will summarize this talk. And first, why we measure the blockchain. A number of researchers are interested in measuring the blockchain. One reason is that the cryptocurrency is a trillion US dollar economy, and we have found that the market of Bitcoin is over 400 billion. And another reason is that the blockchain is designed as a transparency for some informations. To understand the blockchain, security is is critically important to ensure the safety of the crypto assets. And when we do the measurement study on blockchain, we'll meet some ethical challenges. Blockchain network consists of mainnet and the testnet. Testnet is used for some developers to find if their applications can work well in the blockchain, while mainnet is where real applications deployed and where real crypto assets stored. So the researchers tend to do some measurement on the mainnet because it holds the ground truth of development features. However, proactively measuring mainnet poses ethical concerns. So what we want to do is to address the research question that how should researchers conduct ethical measurement of blockchain networks? Here is an example regarding the measurement study. Here, RPC service can receive some queries from the website and then process the method in the blockchain. And the team found that some query is vulnerable, and they can use the query as a DDoS attack to the blockchain when they fill some specific parameters. To verify the correctness of this attack, they need to evaluate in the blockchain. So first, they evaluate it in the testnet of the blockchain. And the testnet and the private node all give some the positive feedback. However, this is not enough because they still need to evaluate in the mainnet. They will face a dilemma between the scientific value and the ethical concerns. Some companies tend to treat it more serious in the mainnet, and they will set some defensive measures in the mainnet service, because the measure is exploitability. The exploitability is deployment specific feature. So the those companies set some method to defensive method. One is load balancing. Load balance force the users to change the node after a period of time or when the workload is too high. And also some service distribute the users to several nodes based on the IP address. So these users, the attacker need to the attacker need to know to discover these defense measures, then to find these flaws. However, this may meet the ethical concerns. It will interfere the service on the. It will interfere the service, and if the service fail to respond the users, then then they will lose some money. So it is a problem. In this specific case, the team designed a lightweight experiment on that, and their method is to measure the trend rather than the absolute value of impact. That is, they want to find how the response time increased when we have the more payload or the more frequencies. They also set a low impact by limiting the duration and payload size. In this figure, we can find that the response time increased significantly when the payload or the rate increase. That will indirectly and nicely demonstrate the effectiveness of this method. And also, we can find that the response time, the largest response time is about 100 milliseconds, which is similar to the normal users. So it means this attack will not affect the user service. In another case, the target is the ETH network topology. The team wants to uncover ETH network topology to learn resilience to single-point failure. And the active measurement method is by sending many transactions and observing feedbacks using the invalid transactions. However, these invalid transactions may interfere the transaction propagations on target nodes measured, and the topology may leak privacy and sensitive information. The team gives two solutions. One is to avoid measuring entire networks in mainnet. They select 18-node subnet in mainnet to measure these 18 critical nodes serving top of the mining pools and RPC. And the second solution is they open source data sets with anonymization. For this, it is hard for attackers to find the weakest link in this topology. They didn't open source the measurement code. And then from the experience we have in this work, we find some ethical challenges. The first one is common practices the researchers will use. The first, they will timely report of bugs to service operators. The companies listed are those companies they provide some bug report or bug bounty interface to users. and the researchers can get engaged in active conversation. This is not only good for solving the ethical concern, but also it will let you to get the approval of the effectiveness from the security team of the company. And also the research need to remove identifiable information in publication to protect the service's reputation. The next ethical challenge is lack of guidelines. Some fresh researchers lack of awareness or guidelines for handling ethical issues. The advisors tend to pay attention to the students' technical ability rather than the ethical problems. And also, the publication may intentionally hide the details on the ethical issues. Researchers it's hard to learn how to handle these concerns to these ethical issues from this paper. The next ethical challenge is the dilemma to request approval. Ethical measurement entails request of approval ahead of time. On the other hand, service providers have no incentive to approve the request. Researchers lack a clear mind on what and how to measure, so it makes researchers face the ethical concern. The next ethical challenge is effectiveness of IRB. Some instructions have IRB while others are not. But even an instruction has IRB, some researchers are not aware of IRB. And it is also very difficult for IRBs to find all the ethical problems in the publication because IRB has no technical knowledge needed. So the instructions has responsibility to educate IRB on technical terms. And the next ethical challenge is limited support for bug reporting. Compared to other fields, most blockchain services are operated by small businesses. Only leading blockchain clients have bug bounty program, while smaller ones have no support. We investigate 4 companies in the blockchain, namely Gas, Open Ethereum, Basil, and Nethermind. And we found that Gas and Open Ethereum occupy 83% and 15% of the market, and they have the website for users to report bugs or bug bounty. That is to say, researchers are hard to contact to other 2 companies when they face the ethical concern. The next challenge is that the responsible result release. Releasing results may raise concerns, and some results are sensitive due to various reasons. For example, it may damage the reputation of the company, or they may expose some sensitive data of someone. And even anonymization measures are taken, sensitive information may still recovered from the publication. Use the doer's work as an example. It make non-RPC services anonymous. However, a small anonymity set of only 9 is not enough, because readers can still analyze the characteristics of these services to uncover the sensitive data. For example, some services supply API keys and others are not. And some services publish their rate limit on their document, that can responding to the information in the paper. So they can still find that they are sensitive data. Okay, here is all the papers we used in this talk. In summary, we reviewing some papers to find how they face ethical concern and how they solve the ethical concern. And also, we identify some open ethical challenges that will met by the researchers. Yeah, that's my talk, and thank you for your time.
Thank you for the talk, and I have a few questions. My first question is in your case 1, I think, and I might misunderstanding, but did you say the testnet and mainnet RPC might be different?
Yeah, the testnet and the mainnet may be different.
Can you explain me a little more why? Because I think the testnet is like mimicking mainnet itself, and
yeah,
I cannot see why.
That's a good question. Actually, the principle of testnet and the mainnet are the same. However, these services give different resources to the testnet and the mainnet. For example, for an RPC service, I only give the testnet one service, so it is easy to be attacked. And if in the mainnet they use 100 services, so when the workload is higher, then the user will change to another node. That means it is hard to attack. So we need to ensure it can be attacked in the mainnet.
Oh, cool, thank you. And my other question is, in case 2, I think you said the topology may give the sensitive information. And can you explain what is the sensitive information? And I assume it is some identifiable information. But in my knowledge, the blockchain saves the transaction ID, and it requires usually the address and usually the data values are hashed. So I'm not sure what you mean sensitive informations.
Thank you for your question. And I think your question is where is the sensitive data in the second case, the topology of the blockchain. In the second case, our work finds how many nodes connected to one node in the topology graph. So some nodes is the weakest nodes in the topology. For example, if we disconnect these two nodes, then the maybe 4 or 5 nodes will be separated from the mainnet. So these nodes are easy to attack. So that's what sensitive data is.